Hi, today we'll make a small workshop and show how to use PuriFi background and integrate PuriFi into a smart contract. So here we have a background dApp. We can connect wallet here. So here how it looks like. In order to use PuriFi, first of all, we need a subscription. In order to make a subscription, we have to go to a stage dashboard. Now we will connect a wallet that will manage our subscription. So this will be my PuriFi demo subscription wallet. So this demo is actually working in Ethereum Sepolia network. So you should have some Sepolia tokens to operate with the board. We're trying to sign in right now. Here we go. In order to buy a subscription, we should have some YUFI tokens. In order to claim some YUFI tokens, I will hit the faucet. So now I have just YUFI tokens. Now I can go and hit subscribe. So I will take a biggest subscription. And then hit subscribe. So now we have a subscription, and we can manage this subscription from the management tab. So we will get back to this tab later on. Let's get back to the playground. So the PuriFi works in the way that the special pivot is constructed on the front end. Then this pivot has to be signed by the wallet, the originating wallet. And then this payload has to go into address of PuriFi issuer. The issuer is validating the data and co-sign this package. Then this package can be returned to the dApp and can be sent in the address of the smart contracts. So that's the whole process. So this process is described here in step-by-step way. So these are the predefined processes and predefined contracts. So we will attempt to use Purify ML, which just actually controls, it verifies the address risk score. And we'll try to integrate this code right now. So in order to do that, I will hit back to the custom. So in the custom tab, we allow it to change all the addresses here. So let's assume that we are going to send tokens from a user address to a smart contract address. So for doing that, we obviously need a smart contract. So we will need to create our smart contract first. I've created my primitive contract here. So these are so it's based on the Open Zeppelin code base, and also it relies on Purify verifier library. In order to install this library, we can use npm install Purify SDK Solidity version 5. I will reinstall it right now to make the process clean. So here, now we have these libraries downloaded, and we can use these libraries in our smart contract. So we have this primitive contract, and we have the only public function here, which is actually called with Purify, will provide the destination address and the amount of tokens, and it will also provide the Purify code data. So this is actually the package that is verified by issuer and consumed by the contract. In this package, there is a data that is required by a smart contract to be sure that the tokens that are sent in the address of this smart contracts are clean enough to be accepted. So here we have verifier validate payload. So this is a mandatory line which actually validates the whole PureFi data. And then we can also get this data out of the package and add some extra verifications that I would like to have. So first of all, which I truly recommend, is verifying the rule ID. The rule ID in PureFi concept is defining the type of verification that is actually performed. So I will set this rule ID in your contract, and then I will use it right here. So if the rule ID is not the one that I'm expecting, I will revert the transaction. So I have a small script that is actually deploying this contract. Let's uncomment it here. Yeah. So I have modified the script a little bit. Here I have my rule ID that we will be using for this smart contract. In PureGround, I have this rule ID right here, so it has to be the same. Then I have a function that is actually deploying this contract using upgradable proxy right here, so that we can change the contract later on and add additional verifications. So let's deploy to it now. Here we have our contract. I will copy in here, paste in here for future.
I will not need it further on.
This is section that. So this is a contract address. In order to purify to serve this contract, we have to add this contract under the subscription first. So we'll go back to the manager and hit add button and in our contract right here. So this way, PuriFi issuer will understand how to serve requests that are attempting to send money into address of this smart contract. So all these requests will be served under subscription, which is right here. Now we are getting back to our playground. Let's try to sign this message. Oops. And you return to change into our contract. And sign in with the wallet. So this is actually the input that been signed by the front end. And this is the output that is going to the address of the issuer. So now we have to press through the verification. In order to pass through the verification, we'll hit send here. It will send this signed package into address of the issuer, and we will have the output here. So this output goes into address of the smart contract. Let's get back to our code. I have created a simple script that will send this transaction in address of the smart contract. We will have to do it quickly because the signed package is time limited. If we will not be able to send it in time, it will expire. Let's try it once again. You can see the transaction came through. Let's go and see it in blockchain explorer. Yeah, so this last one is a transaction that we sent in the address of our smart contract. It's unverified, but you can see actually that there is a number of parameters right here. We can try to send it once again, just to see that it will fail. Yeah, you can see it failing. Because what you can do with PuriFi is that every single package can be used only once. So when you have consumed this package in smart contract, it will not allow anyone to reuse the same package with a different transaction. So let's get back to the code and try to change it a little bit. Let's add, let's say, amount verification. If you go into PuriFi library right here, you can scroll through and see what kind of extra data you can get from the package. For example, let's get token data out of this package. It will return you token address on the amount. And then we will add another require statement here. So technically, I recommend that you require this amount inside the code getter to be less or equal to the one that is in the package. So the package has to define you the upper bound.
So let's deploy and update our contract. We'll get back to our script. There we have to give all the sections. We will upgrade our contract right now.
Here we have our new implementation in Cipolla. So we're returning to the playground. Let's start from the scratch. We have the same contract. Let's change the amount that we have here. So it will be 1,000 tokens. And the token address here, technically we can change this as well, but we didn't verify it inside the contract. So let's keep it as is. So let's sign it.
And send it for verification. Copy and get back to the code. Don't need to jump. Great. So I've got how much and what? Okay, so we have amount
which is actually one Ether here. So the transactions this amount has to go through. It should be successful. Let's try. Yep, transaction was successful. So now we will change the amount to a bigger one. So we will have to use to create another credential Let's try once again. Sign and send. Then copy credential and get back to the code. So we have 10,000 right now. Yeah, and it didn't came through. Transaction was revived with limit exceed. So this is the way how can you use PureFi in your smart contract with additional verification. So there is also an option to use server-side signatures. So these signatures were created by a front end. Technically, what you can do, you can sign this request to PuriFi on the server side. For example, if you have RFQ service or something like that, you technically can employ server-side signing so that user doesn't have to open his wallet and sign this request to PuriFi on his own. So this way, user will even don't know that the system is relying on PuriFi for verification. In order to use the signer, we have a demo package, which is a custom signer. It's right here. So we have it in our open repository, which is a signer backend. You can use it as an example. So I will get back to my repository. Hit. And I will try to use PMI just to be sure everything is installed and updated. We have environment here, so you have to copy environment sample and into this new environment file and change the private key of the signer here and a port.
So there is a fancy command in readme which allows to generate a key. I will use it.
So this is a private key. I will copy it and then to copy environment. So this signer key has to be registered on this subscription so that every single request signed by the signer key is actually served on this subscription. For doing this, we get back to the dashboard and here is a signer list and we will add the signer under this subscription. So we have it right now. Let's get back to our signer service. Yeah, we don't need to we just have to start it. We have it up and running right now. And let's get back to our playground. So here we have our playground. We will use the same smart contract, but this time we will just use our signing background. So for doing this, we have to switch from partners frontend to partners backend. So here is the address of the signer service. We are on 4,000 port as far as I remember. Let's try to sign. Yeah, okay, it works. We have signed it. And then we are sending for verification. Verification was successful. copy this credential and get back to the smart contract, the in library. This credential right here, we will lower down to 100, so that transaction comes through successfully. Let's try. Yeah, the transaction came through. So with this approach, you can have seamless verification, assuming that you are okay with using something like RFQ or signer backend instead of frontend. So with these two options, you can choose either one. Either you rely on the frontend and have a completely decentralized serverless system, but if you can use the server, you can use this option with the signer backend. Basically, here it is. I didn't have anything to add right now. If you have any questions, please reach out to our social media or Telegram support groups. Thank you for attention.